Hello, Math 7 students, and welcome to our fifth video. The fifth video that we will be discussing today is called Identifying Proportional and Non-Proportional Relationships in Graphs. Okay, and my notes start on page 17, so I'm going to turn to page 17 now. Boys and girls, you will notice that we've been working on proportional and non-proportional relationships on tables and in situations, and now we're going to learn how to find them on graphs. So here we go. Page 17 in my comp book. Identifying proportional and non-proportional relationships in graphs. Our goal. Today we are going to learn how to determine whether two quantities are proportional on a graph. The question that I want you to be thinking about is, how are proportional quantities shown on a graph? And I'm going to show you that in just a few minutes. A coordinate plane is another way to model a proportional relationship. So very quickly before we start that task, I need to do a quick reminder of a coordinate plane for you. A coordinate plane looks like this. And I'm hoping now that you see it, you're all going, oh yeah, I learned about those. Okay? This is the x-axis, and this is the y-axis. Mrs. Nelson, wake up. This is the x-axis, okay? So what you need to know is primarily most of the graphs that we are going to be looking at only take place in quadrant 1. So you're going to be focusing on this number line, this y-axis, and this x-axis. So most of our graphs that you're going to be looking at are going to all take place right here in quadrant 1. But I needed you to know the graph that we're referring to is not a bar graph or a pie graph or any of those graphs. It is the coordinate plane, and we're going to be working in quadrant 1. Okay? Again, the vertical axis is called the y-axis. The horizontal axis is called the x-axis. Okay? So now you know that. Let's try it with a task, okay? The task that we're going to be working on is Isaiah sold candy bars to help raise money for student council. For every 2 candy bars he sold, he received $3. Okay? So what is it about? Isaiah selling candy bars for student council. Now we need to read it again, our second read, and look for quantities. Isaiah sold candy bars to help raise money for student council. For every 2 candy bars, there's one quantity, he sold, he received $3. There's another quantity. Okay? So we only have 2 quantities in this story. 2 candy bars, $3. Okay? One more time, reading. Isaiah sold candy bars to help raise money for student council. For every 2 candy bars he sold, he received $3. So the relationship in this story is right there, the ratio relationship. That's a 6th grade thing. For every 2 candy bars he sold, he received $3. Okay? So we know the relationship now. So what we're going to do is we're going to build a table, which you already have become an expert at because that's what we've been working on. So here's our table. And what we want to do with our table is we need to know that candy bars goes in the independent side and money goes in the dependent side because you can't have money without selling something. So candy bars are going to sit on the shelf, but the only way you're going to make the money is if you sell them, right? So money depends on candy bars. Okay, so we've got that figured out. And we were given that Isaiah sold 2 candy bars and made $3. So this is our rate right here. Candy bars per dollar. So 2 per 3, okay? And then what you learned is, how do you fill it out? Okay, so how did I get from 2 to 4? Everybody, how did I get from 2 to 4? I multiplied by 2. That's right. So 2 times 2 is 4. What you do to one side, you have to do the other. 3 times 2 is 6. Nice job. Okay, let's do the next one. How did I get from 2 to 6? Okay, how did I get from 2 to 6? 2 times 3 gives me 6. What you do to one side, you have to do to the other. So what is 3 times 3? 9. Everybody with me? How did I get from 2 to 8? 2 times 4 is 8. What you do to one side, you have to do to the other. 3 times 4 is 12. So does everybody see how we filled that out? Well, kiddos, what happens if you sell 0 candy bars? Well, if you sell 0 candy bars, you're going to make 0 money because 2 times 0 is 0. What you do to one side, 3 times 0 is 0. Boys and girls, does everybody see it? All right, so now we have our table. Our job is to decide if this task, Isaiah's task of selling candy bars, we have to decide if it's proportional or not. Okay? And so another way that we can figure it out besides the table, because we don't know if the table is proportional or not because we didn't find the constant yet, but the other way that we can check is by looking at a graph. And when we use the graph, remember I drew that picture, here is quadrant 1 of that graph. This is the x-axis right here. This is the y-axis right here. For some reason this morning my words are jumbled. This is the y-axis right here. This is the x-axis right here, okay? And then you have to label it. So we know the x always is on the horizontal. So the candy bars from the x go on the candy bars on the x-axis. The money in the y, the dependent, goes on the y-axis on the graph. So money goes on the y, candy bar goes on the x. Okay, and then you just use their numbers that they have. So we need a 0. The 0 always has to sit right here because this is a number line. Then we had 2, 4, 6, 8, 10, and 12. I just kept going because I could. Okay, on this one, however, notice how it counts. So we had 0, then we went 3, 6, 9, 12, and I kept counting 15, 18 if we had to. Okay, so we have them labeled correctly, and now you plot the points. Well, the points that we're looking for are formed by the ordered pairs. The ordered pair is the x and the y. So you're going to go to the right 2, up 3, and make a dot. You're going to go to the right 4 and up 6. You're going to go to the right 6 and up 9. We're going to go to the right 8 and up 12. And so we plotted all of those points right there. We now need to go back and do 0, 0. You went 0 to the right and 0 up, so put a dot on 0, 0. And there's another name for that dot on 0, 0. It's called the origin. Okay, everybody say origin with me. Origin. Okay, so now that we have them graphed, there are some things that we need to look for. Okay, and some of the things that we need to look for is, did it start at the origin? Look at our graph. Do we have a dot at the origin? The answer is yes. Is the line straight? So what that's talking about is when you're graphing a line, so let's say it starts at the origin. Let's say I have a point here, a point here, a point here, a point here, and a point here. Would you please connect the dots? Well, here, 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 here. Boys and girls, is this a straight line? The answer is no, it is not a straight line. Now let's look at this one. Is this a straight line? Yes. Okay. Now the reason I'm telling you this is very important. So does it go through the origin? Yes. Does it have a straight line? Yes. Okay. So that's 2 yeses so far. Okay, let's turn the next page and see what we have to do. So it says, again, write your title on every page. Boys and girls, you have to write your title on every page. Identifying proportional and non-proportional relationships in graphs. So the characteristics of a proportional graph are the points form a straight line. Wait a minute. Go back, go back, go back, go back. Does it form a straight line? Yes, it did. Nice job. Okay. Step 2. The line goes through the origin. Okay, wait. Pause. Go back. Did it start or go through the origin? Yes, it did. Good job. Okay, the third thing that I want to share with you is there is a constant. So now we have to do some math and figure out if there was a constant. So our table looked like this. I'm going to stop turning it back and forth because it's making me dizzy. Okay, so we had 2 and 3, we had 4 and 6, we had 6 and 9, we had 8 and 12, and we had 0 and 0. So now we have to find our constant, okay? So the question is, how do we find our constant? The question is, how did you get from 2 to 3? Remember, we're finding our constant. What happened? Okay, so I have to take 3 and divide it by 2 to figure that out. So 3 divided by 2, right? Because I have to say, what number times 2 gave me 3? Well, I don't know, so I have to take 3 and divide it by 2 to see what I did. So 3 divided by 2 is 1, with 1 left over, so that gives me a half. So the constant in here, sorry, let me write it a little bit spread out so you guys can see it. So here we have it, times what gave me 3, times what gave me 6, times what gave me 9, times what gave me 12, times what gave me 0, okay? And so we now know that 2 times 1.5 gave me 3. Okay, so let's check this one. 1 times 4 is 4. I'm seeing a pattern. I hope you guys are. Okay, so then the next one is what times 6 gave me 9? Again, I don't know, so I have to do the division. 6 goes into 9 one time. 9 minus 6 is 3. Leftovers. Oh, that can be reduced to 1 1/2. Boys and girls, are you seeing a pattern? 1 1/2. Okay, now I have to say, what times 8 gave me 12? So I have to take 12 divided by 8. 8 goes into 12 one time with 4 leftovers. 4/8 is the same thing as 1 1/2. Boys and girls, I'm getting so super excited. So should you be. What is our constant? 0 times 1 1/2 is still 0. Yes or no? Yep. What is our constant? 1 1/2. So kiddos, was there a constant? Yes. Did the points form a straight line? Yes. Does the line go through the origin? Yes. So now it's proportional. Okay? Very quickly, because you heard the bell and I have a new class, your task is to complete what we just did on this one. Okay? I want you to do this by yourself, and that's what we're going to be checking when you get to school in the morning. All right, my dears. Thank you so much for your hard work, and I'll see you soon. Bye.